Hello sir, tell about yourself and your company sir.
So myself is Dr. S.A. Channiwala, Dr. Salim Channiwala. I did my M.Tech and PhD from IIT Bombay. Then I joined the institute Sardar Vallabhai National Institute of Technology. It is a national institute in 1981. Served the institute for nearly 38 years in various capacities as a head mechanical department, as a dean postgraduate studies, and as a director, in charge director for 3 times at the institute. And then I retired in September 2019. Now what next after my retirement? That was a major challenge. There were many offers to me because being from academics, I would have continued the academics, but no. I realized one fact. I have lost 4 of my relatives in cancer. I studied the root cause of cancer, that is the use of your chemical fertilizers and pesticides. So I decided to go organic. So that way we can serve the mankind. And based on this mission, I started developing waste to wealth projects. Mr. Zuhair came to me in 2017. They were along with his friends who were diamond industrialists, and they wanted to serve the society. I talked them about my mission that yes, I will join with you only if you follow my mission. Whatever wealth we generate, it must be at much reasonable rate and it must reach to the farmers. It must be responsible for improving the quality of environment, the quality of soil. It must generate local employment, and ultimately it must improve the quality of life of human beings. They agreed. So I took up design of this particular plant in 2017, completed the whole design part in 2018, including the installation of various components of the entire plant. This is basically a, you can say, bio-CNG plant. The input we use is your chicken waste, the gobar, vegetable waste and food waste. The daily intake capacity of the plant is 50 to 75 tons per day. The output capacity of the plant is about 2200 kg of bio-CNG, 70,000 liters of bioorganic liquid fertilizer and 20,000 kg per day of solid organic fertilizer. This is output capacity. At present, we are operating only at about 15 to 20% capacity because our gas outtake by IOCL is limited to 400 to 500 kg only. Now coming to the process, this is an anaerobic digestion process. The feedstock is fed through a specially designed feeding system. It is fed in a controlled manner through automatically controlled flow meters and valves to the digesters. In the digester, it goes anaerobic digestion process. This process is of 3 stages. First stage is hydrolysis, second stage acid fermentation, and third stage is methane generation. All this happens under the controlled atmosphere of pH and temperature. In order to maintain this temperature, we have provided a certain heating system which I will take you and show you at the digester itself. After digestion process, we get gas. That gas is taken to the purification system where we maintain the gas purity as per IS standard, more than 93 to 94% of methane. And then we cascade, we fill it through a CBG compressor to the cascade, and this cascade is supplied to a CNG pump, bio-CNG pump, which is being operated by IOCL. The slurry which comes out from the digester is an anaerobic slurry. And let me share with you that unfortunately in the market most of the organic fertilizer which is being sold is this anaerobic slurry. This slurry has a much less nutritional values. It contains pathogens, so it does not have much nutritional values. So it takes the amount of this slurry consumed is much higher. The growth is not that much significant. As a result, farmers are discouraged to use this particular slurry. Now this has to be addressed very critically. So though myself being an engineer, I studied the process of plant growth. the physiological processes, and then mathematically devised a system wherein I can enrich this slurry. Now the basic is the anaerobic condition, the bacteria will not survive under aerobic conditions. So you need to give aerobic treatment, simultaneous anaerobic and aerobic treatment to this slurry, along with addition of different quantity of different organic materials, so that you achieve a desired level of NPK and organic carbon. I have focused more on organic carbon because our soil content in India has gone down to less than 0.4% organic carbon. So we need to enrich it, because all bacterial activities and plant growth will survive only through organic carbon. So we focus on organic carbon, and whatever liquid fertilizer we have come out has organic carbon more than 4.5% in general. Whatever solid we have come out, it has organic carbon more than 21% in general, and that's why this gives you the best possible results without use of any chemical fertilizers. Today we have sold about 3 lakh liters of this liquid tonic. More than 600 farmers are deriving benefit of this particular fertilizer, and that is the greatest part of satisfaction in my life. Now I will take you to the plant. So some details of the plant I will share with you. Being an academician, I will not hesitate to share you majority of the details of the plant, right? So we will go to the plant. We will start from the feeding system first.
Can you explain me about this plant, sir?
Yes. So first thing, before I designed this plant, I studied the majority of the plant across the country. Most of the plant is facing a problem of digester jamming. Now this digester jamming occurs because of the deposition of debris. So the first step must be that your feed must be free from all debris. So the fundamental requirement is to carefully design a feeding system. So you can see here, I have designed a multi-screen feeding system. First bigger screens, then smaller, then smaller, then smaller, and finally there is a mixing chamber. This means that all debris, all your fibers, all heavy stones, they will be collected into this feeding system. And when we come here, then whatever is the additional organic material which we intend to feed, it comes from this pulverizer. So that pulverizer we feed the organic material, additional organic material, and this mixed slurry enters into this mixed slurry is entered into this mixing chamber. Now in this mixing chamber you can see there are three propellers. So we give a mixing of about 30 minutes to 1 hour before we take it to a digester. So whatever slurry comes, it is now debris free, it is now fiber free, and entire system is patented by me. Let me share with you that every component of this plant is designed and patented by me. I don't believe in going for any imported technology. This technology is 100% my own technology, and we have patented it. And let me share with you that it gives the design results. Whatever design I conceived, probably slightly superior than what I designed, results we are getting through this particular system. Now if you come here, we have provided 2 slurry pumps here. Now these slurry pumps are also designed by myself and patented, because normal slurry pump has efficiency of about 25 to 30%. I improved it to 45%, and that's why this new design we have also patented and kept it for here. Now whatever slurry comes, it is fed from these 2 pipes. Why 2 pipes I have used? In case of failure of one pump, second pump can be operated. So one of that I have kept it as a reserve. Alright. Now from the pump, the slurry comes into this common header. This common header is to supply the slurry to the 3 different digesters. This is a digester 1, this line, this is a digester 2, and that one is digester 3, which is yet to come up. Right. Now every digester is fed with measured quantity of feedstock, that is slurry. This is a magnetic flow meter, and everything is controlled through the computer. How much I need to feed in digester 1, it will feed, then it will go to digester 2, this is based on my input data, and then digester 3. So everything is through computer control. Now from here, Say this slurry comes from here, and this is a feeding line. This feeding line is designed in such a manner the slurry is fed at bottom level as well as at middle level, so as well as from the top level. So I can feed the slurry at 3 different levels. That is must, because in a larger digester you need to supply food to the bacteria, and hence the 3-stage feeding is provided. Further, you can see here, this is a heater. In order to maintain temperature, we recirculate the slurry in the digester through this electric heater and maintain a temperature of about 37 degrees centigrade, which is optimal. So whatever gas is generated in this digester, it is taken out from this exit pipeline, gas outlet pipeline. You can see here there is a valve which is electronically controlled.
Okay.
So that how much flow I want to take it out from a digester, that can be controlled. Then you can see here, this is one specially designed vessel which is known as a moisture trap cum flame quencher, which is a safety device for the digester. The gas moisture is collected, and if any backfire takes place, it will not travel to this digester. So it's safety. Similarly, here there is one more safety. This is a flame trap. So there is safety against any flame created. That flame will never reach to the digester. Otherwise, it will create a havoc. The gas flow is measured by a thermal flow meter. So I know what is the quantity of gas going out from the digester. So everything is available on my computer screen. Right? From here, this gas goes to, say you can see here another tank. This is a balancing drum. Because we are using 3 digesters, it will have a different pressures. So in order to balance this pressure, the gas from all the 3 digesters comes to a common balancing drum. And from the balancing drum, this goes to the purification system. Say from the balancing drum, whatever gas comes, it is a dirty gas or raw biogas. So it needs to be cleaned first. So your H2S, HCl, all acidic component needs to be scrubbed. So this is a Venturi scrubber in which these gases are getting scrubbed.
Okay.
Okay, next come. This scrub gas then comes to this purification system. It is a PSA based technology. So whatever is the excess CO2, it is being removed. H2S is come to 0 to scrubber only, and you get a methane content in finally purified gas of the order of 93 to 99%. We maintain at 93 to 94% because it is a requirement as per as standard for vehicular propulsion. So the gas which comes out from here goes to the compressor. So whatever gas from purified gas from a purification system is taken to this compressor.
Okay.
Compressor compresses it to about 250 bar max.
Okay.
At present we have approval up to 150 bar, so we compress it up to that. And then from the compressor it comes to this filling station. We have got 2 cascades of 20 cylinders. So from that, this high pressure gas is filled into this cascade 1, then into the cascade 2, and then this cascade is taken to IOCL CNG pump, where they will fill it to our vehicles. So it is being used for vehicular propulsion.
Okay.
So we call it as CBG, compressed biogas.
What is the per day capacity for this, sir?
Yeah, it is one cylinder has a 75 liters capacity, right?
Okay.
So there are 20 cylinders, one cascade. Salary is 20 cylinders, another cascade. So you can see 1500 liters in one cascade, 1500 liters in another cascade.
That's the per day capacity.
Cascade, yeah.
Yeah.
And one cascade weight wise, it is about 225 kg
Okay.
gas, bio-CNG gas. Yeah. Say we have seen the gas generation process, right?
Yes.
Now in case our compressor is out of order, the generation will never stop. Or if anything is under maintenance, generation is never stop. So this gas has to be flared out. So this is again a specially designed flare stack only for biogas. Again, let me say it is a patented design by us, right? So this is our gas circuit. Now come to the fertilizer part. There are 3 digesters. All the digesters outlet is in a gradient. So outlet slurry which comes out, the digester slurry which comes out from each digester is first collected into this slurry collection tank. It is an anaerobic slurry, I repeat, it is an anaerobic slurry. Now here, after collection, we give it an aerobic treatment, aerobic. Then after giving that treatment, we take it to our fertilizer tank.
Okay.
And here we add series of organic substances, nearly 45 organic substances we add in a sequential manner. And again this system keeps on running as per the design mathematical timing models, how much time it should be aerobic, how much time it should be anaerobic. Then finally from this slurry we take it to the final fertilizer tank. I will take you there. So these two are our final fertilizer production tanks.
Okay.
Whatever slurry we have enriched there,
Okay.
it comes back to this tank, we test it, and then any further nutrition is required, we add further nutrition. After adding this nutrition, we filter it to 120 mesh through this filter, you can say vibrator, and this liquid, why we filter it to 120 mesh, so that it can work in your all dripping systems. Your nozzle will not get jammed.
Okay.
After this liquid is separated, the last stage is we add our own culture. Okay. And this final liquid, which is enriched with our microorganism. These are also developed by us, one of our colleague, Dr. Bhai, and that we add it. We add, say, most of the microorganisms are getting generated within the system itself, but we further enrich it to your nitrogen, then potassium mobilizing, then phosphorus mobilizing, then all you can say trichoderma and others. These are being additionally developed, added into this liquid. Now this liquid then again is given that aerobic and aerobic treatment is continued. So when we feed our kerba, that is for final product, into your kerbas, it is coming in your hand after 75 days. There is the most matured category of liquid fertilizer. Now whatever solid is left out from here after filtration, this solid we take it to our solar sterilization system. You can see there. We will go there. So this is my special designed solar sterilizer. Here we maintain temperature of about 60 to 65 degrees centigrade, and all your pathogens are getting eradicated. And bacteria are trained to work under the worst atmospheric condition. This fertilizer works even in desert region. It works even on seashore where highly salty sand is available. So this is the level of sterilizer. And then one more thing.
So it is suitable for all types of soils?
All types of soil, yeah.
Okay.
Yeah, it is suitable for all types of soil.
Okay.
We keep on adding certain organic materials on every alternate day. So this is getting enriched and enriched, and 21 days we take here also in this process.
Okay. Sir, what is this place, sir? Can you explain me about this place?
Yeah, sir, this is a laboratory.
Okay.
Let me share with you, the very first thing I did was establishment of a good quality laboratory before starting my digester construction. What we do here is, whatever feedstock comes, we develop different ratios of mixing and then put it for experimental digester. Which composition gives me the best gas as well as the best quality fertilizer that we select for feeding to the digester. So this is my, you can say, R&D lab.
Okay.
Right. This is the pH record of the various stages of the slurry, starting from low slurry to the intermediate slurry to the final slurry and to the final product which we are selling. And this is maintained day to day.
Okay.
Day to day.
So daily you will be writing this
yeah,
pH level?
Daily.
Okay.
You can see the date today.
Okay.
We are eliminated this because it was full, so we are starting from today, 8 August. Right? So these are daily measurement, and that is why I repeatedly say everything what we do is a highly scientific work.
Okay.
All record we keep day to day. Any product which goes out is a batch given. This batch is analyzed by an NABL accredited lab. Environmental Innovation is an NABL accredited lab. And with that certificate only, the material goes out of this particular premises. Okay. Second part, we have analyzed the product, liquid, for residues in National Horticulture Lab Nasik, which is India's premier laboratory. And they have certified that this product is free from 263 residues which are responsible or which are dangerous for human health. With this certification, we can go for exporting this material. Second part, we have also received an NPOP certification of the product. So any farmer who wants to use it or anybody who wants to export it, he will not have any queries that what quality of fertilizer he is dealing with. He is dealing with 100% organic fertilizer, right? Yeah, you can see here, this is our SCADA screen. So this is a specially designed computer program to which I can control all the activities of the plant just sitting on this particular computer. What is a condition in digester 1 is known. What is in digester 2 is known. What is in digester 3 which is yet to come up is known. How much feeding I am doing, what kind of pump is working, which blower is working, everything is visible to this particular small figures. At present everything is off because circulation is stopped, no feeding is done. So you can see none of the pump is working. Moment I start pump, it will show rotating and you will see that it is working. Right? So it is how much is to be fed, how much heating is to be given, everything is given from here. Say for example, say this is a digester 1.
Yeah.
What is the temperature inside and how many heaters are on so as to control the temperatures above 30 degrees centigrade, that everything is visible on the digester, right? So this is about a temperature control of digester 1. Similarly, there is a flow control. How much flow I should supply, that is also another circuit.
Okay.
So everything is controlled to the computer.
It's fully automatic.
Fully automatic.
Yeah.
100% automatic.
Okay.
And you can see here our panels.
Okay.
All panel which we have designed, they meet the international standards, safety standards. No compromise. You can see even the quality of this.
Okay.
Quality of all is L&T, major is the and Schneider. So international standard we maintain here, and everywhere we have kept our instructions. You can see here.
Okay.
The safety instructions.
Okay.
Now finally, let me share with you this feed, this outlet fertilizer can be used as a very good fish meal, fish food. It has a protein content more than 22%, and we have supplied it to few fish farms, even Jinga farms, and the results are excellent. We are now specially developing a product for fish also after getting these satisfying results. Right?
Tell us about your team, sir.
Yeah. Say Channiwala alone cannot do anything. Anything which comes, it comes out as a teamwork. My team, you can see here, Zoharbhai Lokhandwala. He has worked day and night from morning 4 to next day morning 4 in the fields to bring out the results. He is a CEO of the company. He is a Rasikbhai Varia. Water fertilizer we have developed, a very good contribution is from his side. He is a BSc Agri. So a lot of information and the field work he has done. He and Zoharbhai has done a tremendous field work to bring out the field results. And after getting field results only, we have put this product in the market. So he is a sales director of the company. Sailesbhai is a plant manager. Everything, operation of the plant is managed by Sailesbhai. All dispatch of the fertilizer is managed by Sailesbhai. So, and one more person who is missing here is Khozem Misri. He is a technical guy who looks after the technical aspect of the plant. Normally I visit a plant only once or twice a week. Otherwise, your plant activities is managed by my entire team. Now the final statement. I have been awarded with prestigious Bhatnagar Fellowship. This is only for my social contribution throughout the life. And Bhatnagar Fellowship, you must be aware that it is treated as equivalent to Indian Nobel Prize. But I very humbly work for the welfare of the society. Thank you very much.
Thank you for your time, sir. Thank you very much.